Hey, welcome. Thanks for joining for this session on sustainability and slogans and myths and strange stuff around that. My name is Martin. I work in Hamburg and I live in Hamburg, and I work for the Spring Core engineering team at VMware. That's the team that is building Spring and Spring Boot and all those kind of things. You might have come across those frameworks being used for stuff like Netflix and FedEx or whatever. So widely used stuff. And I really enjoy that because I'm super passionate about software engineering. So I'm in software engineering for probably, I don't know, maybe 30 years or 35 or whatever. And I really love that. I love that so much that nowadays I kind of develop software for other software engineers and tools for other software engineers to help them and make them more efficient. And that's really at the core of my interest day in, day out, right? I'm really a software engineer. And probably 15 years ago, when I was working at IT Agile with colleagues, we also thought about beyond our work a little bit, and we thought about what is our work has, what's the impact that our work has on something like the environment. So we looked at stuff like, we did consulting stuff, we were flying around a lot. That's probably not that good for the environment. So can we do something about that? And there was a company called Atmosphere back then. They still exist. And we thought about, okay, we should kind of compensate for our flights, right? So we should pay and invest money into these projects to offset our carbon emissions and things like that. And this sustainability topic and this taking care and caring about the environment also kind of became one of my big passions in life. And a few years ago, I actually started to think about, what happens if I actually combine those two topics, those two things that I'm passionate about, software engineering, as well as taking care of the environment and thinking about climate change and stuff like that? And what's the connection between those two topics? And I started to investigate this area and research into that a few years ago, think about what's the impact that we as software engineers can have on climate change? What can we do to prevent that from happening? What can we do to save the environment or whatever? What's the impact that we can have as software engineers? Because software is everywhere, right? It's in your pocket, in your phone, millions of lines of code, data centers. And if you have seen all the other talks about sustainability, you've probably heard these numbers like the carbon emissions in the IT industry. It's kind of the same size as the airline industry, right? So it's a big chunk, right, of the problem. So what can we do about that? And on this journey, investigating those things and looking into different things, I was fairly new to some of the topics, very new to some of the concepts behind that. And I came across a lot of these, let's say, slogans and words that you might also heard. But when we look at the software engineering space, you might think about the question. Yesterday there was a question about, should I choose a different language to be more energy efficient, right? Things like that. And maybe we as software engineers, we always think about, the code and the stuff that we run. But it's actually a lot more. So the goal is we need to decarbonize everything in the long run, or hopefully in the short run. And that's a lot more than just the code, right? It basically touches all the aspects in your life as a software engineer. And sometimes it's even kind of surprising. There are kind of software companies, they do software, but the majority of their carbon emissions being produced by people commuting to work in the morning and commuting back home. That's a big chunk suddenly. Oh, interesting, right? So you need to look at this from a more holistic perspective, I think. But down the road, we need to decarbonize everything. And this is actually extremely difficult. This is not an easy thing to do, right? There's nothing we can just do and it's done. But interestingly, even though it's super difficult to do and to decarbonize all this stuff, it sometimes sounds like we are already there. If you take a look at let's say at the advertisements, at the marketing statements, whatever, right? So maybe you run your stuff in the cloud, and maybe you've seen something like, hey, we are running on 100% renewable energy. Oh, we run on this green cloud. oh, we do X, we do Y, we do Z, we are on a net zero plan for whatever. But what does it actually really mean? It all sounds awesome. It sounds great. It sounds like we as software engineers, perfect. Let's sit back. They all solve the problem for us. We can relax. But that's actually not true. So let's dive into the details and take a look at some of these concepts to really understand what's behind all those slogans, to really get a better understanding of all that. So you probably have seen something like at the supermarket, at your cloud provider, maybe at your cell phone producer, whatever, we are 100% carbon neutral. That sounds awesome. Perfect, 100% carbon neutral. That sounds great. Some even say, oh, we are net zero. That sounds even better. But what does it mean? What does it mean if you buy something that is 100% carbon neutral, or you do something that is 100% carbon neutral? If we think about that, if we think about reducing emissions, because producing something, building something, running something causes emissions, if we think about reducing emissions, we basically differentiate between eliminating emissions, so not putting carbon into the atmosphere, and continue to put the same amount of carbon into the atmosphere and offset that. So try to do something about these emissions that you caused. And in this space, we differentiate between compensate for something and neutralizing. So neutralizing is basically you try to rip stuff out of the atmosphere again afterwards, which is quite complicated, usually takes a lot of time. It's really difficult to do that. Or offsetting in terms of compensating. So you try to pay someone else to not emit carbon into the atmosphere. Because if you would not do that, you would not pay that someone else would also emit carbon into the atmosphere. So instead of kind of putting twice as much carbon into the atmosphere, you say, okay, I continue to put my stuff into the atmosphere, but I pay someone else to say, please don't do the same shit that I did, right? And I give you money for that. Which is kind of weird because it doesn't really solve the problem. You still put the stuff into the atmosphere and it still heats up and whatever. And all these projects about compensation, they're really, if you look at all these projects, they're really awesome, really good projects. They really make a lot of sense on their own. Like you invest in planting trees, which is more kind of neutralizing. You invest in keeping forests alive. You're investing in other projects. They all make sense, right? They're all good. So please do all that. But please don't think about it. It does anything about the stuff that you put into the atmosphere, right? That is still there and that will be there for the next decades, right? So if we think about carbon neutral, if you do all this, for example, you compensate for everything, so you pay someone else to not do that, and that's all, then you can say you're carbon neutral, right? So that's basically what most of the companies do, right? So if you see a label carbon neutral, you should really ask for, how did you achieve that carbon neutral thing? Do you just compensate? And if you compensate for something, you pay someone else, who exactly do you pay for that? If you think about net zero, that takes the compensation part out of the equation. So you try really hard to not emit carbon into the atmosphere. And for the remaining thing that you cannot eliminate, you try to neutralize. So you try to get that out of the atmosphere again, for example, by planting trees or investing in projects. Also difficult because planting trees, that usually takes, 80 years or so until the stuff is being compensated out of the atmosphere again. So offsetting doesn't solve the problem. We talked about that. So we really need to think about eliminating emissions just to get these slogans clear about net zero, carbon neutral, right? Really important. And that applies beyond IT. The next thing that you sometimes hear is that, oh, this cloud or our data center or my computer, we are running on 100% renewable energy. So don't worry. Right? You don't have to worry. You can run your stuff on this data center. It runs on 100% renewable energy. And that is actually, what this really means is we buy as much renewable energy as we consume in total. So when you ask people, you usually hear, oh yes, we have a contract with a renewable energy provider, and we pay them to produce renewable energy in the same amount of the energy that we consume, which is sort of good. But it doesn't mean that your stuff runs on renewable energy all the time, because renewable energy is not available all the time. And it's not available all the time in the same amount that the data center, for example, consumes the energy. And if you look at the data centers around the world, and I think I saw one of the slides about 8,000, more than 8,000 huge data centers. I think there are one or two on the planet that are really able to run everything 100% on renewable energy all the time. Two of them. Everything else is still consuming energy produced by coal, produced by burning fossil fuels, at the moment in time where it needs more energy than renewable energy is around. And things like these kind of new kids on the block, oh, there's AI coming around, oh, there's Bitcoin mining, whatever, it makes it even worse, right? So you consume even more. So there's not enough renewable energy production yet to really cover that all the time. And the problem is that the data centers consume so much energy, and we tend to put more and more stuff on those data centers and run more and more software that they consume more and more energy. Of course, you can sit back and wait until they achieve, oh, we run everything on renewable energy all the time. Right? But that is a that's quite some time away, right? That's nothing we can do right now. It will take a long time. And if you continue to increase the energy consumption all the time, maybe at a higher speed than you were able to add renewable energy to the grid, you will never match. So it is a big problem. So we need to think about the way we consume energy, not only how we produce energy. The next thing is, if you run your stuff on a data center sometimes, and probably you all do that, and I did that as well, sometimes people think about, oh, if it's not used, it doesn't consume energy. So you deploy your system, sure you all run systems on the cloud or on some infrastructure, so it runs, and maybe it runs all the time, maybe it runs in the night, who knows? Who's shutting down the machine physically at night in your data center? So who's going down to the basement and say, yeah, no one, right? It's all running. It runs day in, day out. Your testing environment, your integration environment, your staging environment, it runs all the time. And even if you don't use it, if you just have your stuff deployed, and no one is using it, right? It still consumes about 50% of the energy, of the total energy. Of course, the CPU is clocking down, and there are energy-saving mechanisms in place and all that. And that is, it consumes less energy than if you would use that under kind of high load. But you cannot really go much below 50% of the energy consumption. So you can imagine how much energy you just waste by having it running or having it deployed in your data center without really using it, without really utilizing it. And this goes way beyond this problem of you have your stuff that you usually use and you have deployed. There are studies looking really at data centers and what software is running at data centers. And how is that software really being used? And the company that I work for, VMware, they did that as well. They did something like they had a data center, I think in Singapore or whatever, and they had to move the whole data center to a different location. So they did some kind of, they looked at the inventory basically and see, okay, what is really being used? What do we need to move over? And in the end, they figured out that 2/3 of all the stuff that was running in the data center was basically not being used at all. 2/3. And you can think about, yeah, you're these kind of infrastructure guys and these hypervisor guys, so you test a lot of stuff, and that's not comparable to real world stuff, right? And that is actually true. So there's a study who really looked at data centers in the real world, real applications, real data centers, thousands of them, thousands of applications. And what they figured out is that in those data centers, they grouped stuff that was deployed in these data centers in 3 categories. One was not being used at all, 0. And they kind of measured that over, I think, a period of 6 months or so. So not being used. The second category was below 5%. So whenever they measured something, in just 5% of the cases, this thing was alive and it was being used. And used means kind of interaction, CPU, memory, network, whatever, any kind of interaction, any kind of activity. And the third group was kind of basically the rest. It was used more than 5% of the time. And the numbers are really stunning because they figured out in these real world data centers, it was kind of roughly, just rough numbers, 1/3 was in category zombie, not being used at all, 1/3. The second category, below 5%, another third, roundabout. So this is a real problem. And I'm 100% sure that all of us, and including myself, we deployed stuff. It was running there. We didn't really use it anymore, but it was still running, and we forgot to shut it down. We keep it running, but we don't really use it. We just use it rarely for some stuff, but for the rest of the time, it is just consuming energy, wasting a lot of time. So don't think that if you don't use it, it does not consume energy. As long as it's deployed and running on the cloud, in your data center, whatever, it consumes quite a lot of energy. And there's, in many cases, quite low-hanging fruit to get rid of that and really clean that up to save a lot of energy. In addition to that, of course, you can also think about the size of your deployments, the container sizes, right? So how big is your container? Do you really need all this memory? When I talk to people about things like that, and I ask them, it's sometimes like, yeah, we don't exactly know, but just to be safe, let's give it a little bit more memory, just to be safe, right? Just kind of as a buffer somewhere. A little bit more memory, maybe a little bit more CPU than we maybe really need. Oh, maybe take a size of the node, the machine size. Let's make it a little bit bigger, just in case. In the end, most of the time you don't use that. It's just wasting resources. The next thing is that some people sit back and think, yeah, forget about all these optimizations and whatever. That's weird stuff. Consumes a lot of time, costs a lot of money in developer time. The hardware will take care of that. The hardware will be more efficient, which is indeed the case, right? The hardware will be more efficient. So you can run stuff on today's hardware that wasn't possible 5 years ago, something like that. But don't ignore the rebound effect. So the more efficient the hardware is, the more software you will build to consume all that. And probably the slower the software will be because you think, aha, the hardware will be so fast, I don't need to think about that. I don't need to care about optimizations. I don't need to care about a little bit more, a little bit less memory, whatever. Just, it's cheaper to get more memory. It's cheaper to get a bigger machine than to invest another day in optimizations, than to invest another thing. Right? I guess some of you have been to the fireside chat with David Heinemeier Hansson yesterday. So what did he say? He said, oh, it was cheaper to get stuff out of the cloud into your own data center and buy machines yourself. Probably true for many cases. Right? Not for all, but for some. It was cheaper. But what happens to these machines when they actually don't use them? In the cloud, you get a lot more density, right? You can run a lot more stuff on the same hardware. If you just buy the hardware and you run the hardware all the time yourself, maybe it's cheaper, but it will most likely be worse for the environment because no one else can also benefit from the same hardware resources than, for example, people would do in the cloud or in some kind of shared environment. So don't always look at, I think that's something that I think, don't always look at what's the cheapest way to run those things. And this is a big problem because if we look at the energy consumption in data centers, at the moment it's about kind of 3 or 4% of the total energy production in the world. But if we continue on the same path, it will probably be around 10% in the next few years. So let's think about 2030 or whatever, 10% of the whole energy in the whole world will be consumed by data centers. And why do those data centers exist? What do? They run your software. So if you can make your software better, if you can delete your software, if you can make it more energy efficient, if you can make it so that it only uses half of the memory, half of the CPUs, whatever, and you scale that up, it has a big impact. Of course, a very old law, but keep that in mind, right? That even though hardware is getting more efficient, I'm not sure if you really have the feeling that your Windows laptop is probably 1,000 times faster than your Windows laptop 10 years ago. Who really has that feeling? Right? Probably no one, including myself. There's more stuff running on it, stuff getting slower. So it eats all the capacity of the hardware. And that's the problem of the software. And the software is the stuff that I care about, building really awesome and great software. So there's no real way around building better software. That's what I would like to encourage you to also think about. Build better software. Really think about that. Really take that into account. Software that uses less hardware and less energy. If you would like to know more details about how to do that, there is something like the Green Software Foundation giving you a lot of advice. There was a talk yesterday by Anita. She had a great Miro board with a lot of stickies, a lot of links to all the different things you can do, a lot of patterns, a lot of measurement tools and things like that. So please take a look at that. That is an awesome resource of additional input. So take a look at that and do it. Let's do it. With that, I'm on time. So that's awesome. I didn't see this sign, sorry for that. And of course, I would be super happy to answer questions, discuss stuff, and chat with you about those things. If you have any questions or any comments or anything. Anything?